Okay, now that we know our solve data is pretty accurate and will probably work just fine for us, we want to start trying to create a more accurate surface for the face. So for now, I'm not going to need these cubes anymore. I'm going to go ahead and delete that checkerboard. And what I want to start doing is trying to come up with a more accurate point cloud. Now, this point cloud here is great. It absolutely served its purpose, helped us understand that the solve was accurate, it was in the right place, and it doesn't look half bad either. However, we now have an accurate camera. We can use that accurate camera to create an even more accurate point cloud. This point cloud here is almost more of a byproduct. These are points that were used to create a proper camera track. So imagine we can get much higher quality if the camera is already there. So to do that, we can use something called the point cloud generator. I'm going to go ahead and type that in here. There's our point cloud generator. And let's take a brief look at just how this node works. So the first thing I need to do is give it a camera. So attach it to the camera right there. You can see it could also potentially use a mask, which I'll go ahead and hook it up to our roto over here. It's going to be a little messy, but let's go ahead and hook up that mask right there. Once we figure out where all our nodes are going to be and how many we'll have, we'll go ahead and get this all cleaned up. Right. And in addition to that, I also need my source. The source is going to be the footage. And since the camera's already solved, I don't mind if there's noise and things like that in the footage. I'm going to connect to our original footage right over here. So in order to make the point cloud generator work, the first thing we need to do is set up the mask. Otherwise, it's going to use the entire piece of footage. We want to save some time. So I'm going to tell it to use the inverted alpha of my footage. That's going to use the inside of the mask. Or rather, it'll keep the inside of the mask. So the next thing I need to do is tell it what frames it needs to analyze. And we have to set keyframes. Now, there's a variety of ways we can actually do that. I could hit analyze sequence here, and what it's going to do is analyze every frame, kind of track the points, and figure out what it thinks are the most valuable keyframes that it should be using. So the other thing we can do is manually add keyframes. I can go and pick whatever frames I want. Ideally, you'd be looking at the 2D footage here. Pick whichever frames I feel are keyframes, and I can add those manually. Or I can add them in batch. For example, I could tell it, give me a keyframe every 20 frames. Hit add all, and you can see these little blue ticks that have been added there. They're a little hard to see, but they're there. Those are now keyframes every 20 frames. Go ahead and hit delete all there. So for right now, we're just going to do a very kind of basic test. In our next clip, we'll go ahead and set up a very accurate one. So let's say I want maybe every 30 frames. So it's going to be roughly 11 times that it's going to sample. So 11 keyframes. So I'll hit add all. There we go. And now let's go ahead and take a look at these settings here. So refers to dense tracking. So point separation within dense tracking is how far apart the points are going to be. You can almost think of this as pixel resolution. The smaller this number, the more pixels or points I'm going to have. I'll go ahead and put it maybe to 3 now, just to be a little faster. Track threshold is almost like quality. The lower this number goes, the more it's just going to be more likely to grab points and decide they're correct. The higher this goes, the more it's going to have to try to figure out if they are correct, and if they're not, it's going to toss them. So we'll leave this as is at 0.7. So at this point here, let's go ahead and just hit track points and see what we get. So 1 to 344 is what I want. We'll hit OK. And this can take a little while. This one should go fairly fast. You can see here it's only going to be about 30 seconds. But still, rather than wasting time here, I'm going to pause. Okay, that was actually pretty fast. And you can see that it's now created a point cloud for us. So let's go ahead and try to visualize it in 3D space. And you'll notice that there is some color data here kind of hiding behind the other point cloud. So we can go ahead and hide that point cloud and see what we got. And it's really not a whole lot of data. It really just looks kind of like roughly half the face there. And that's going to be primarily because of the fact that we really only used a small handful of keyframes. What was about 11 total we estimated, maybe 12 at the most. However, you can see that it tried to sample color, and it's actually already, even at these low settings, starting to get a much more accurate shape. Now, areas like the nose have completely fallen flat, but you can see we have a nice curvature to the face there. So you can imagine at higher settings, we can start to get a much more accurate point cloud. So we even have settings over here to help us kind of get rid of rejected points. So you can see there's an angle threshold. So as I increase that, you can see it rejects certain areas that are outside of that threshold. You can also hide those points. You can see it slowly kind of eats away at the surface there. We can also get rid of points based on density. So if any area has too many points, we can slowly begin to remove those there. At the moment, neither of these are really doing a whole lot for us because there really just isn't very much there. But anyway, that's a basic look at how the point cloud generator works. What we'll do in the next clip is set this up specifically for this shot and try to get a very dense, very accurate point cloud that we can actually work with to begin creating our surface. So, see you in the next clip.